Alright, today we're talking about multiplying decimals using an estimation strategy. There are several rules when it comes to multiplying decimals, but we are actually just going to look at a strategy that can work for any way you multiply, whether it's lattice, traditional method, partial products, a rule that will work for any of these methods. And it's got 3 steps to it. The first step that you have to remember is to first make an estimate, which makes sense if we're calling it the estimate strategy. So you want to estimate the product. So I'm going to say, what do I expect to get when I multiply these two numbers together? Once you have that estimate, you want to keep it in your back of your memory, maybe jot it down so that you can remember what you expect the product to be around. The second step is you're going to multiply the two numbers, the two factors, but you're going to do something kind of weird, is you're going to ignore the decimals. So I'm going to treat the numbers like there are no decimals there, and they're just whole numbers. I know how to multiply whole numbers, so I should be able to multiply those. Once I have that product, I'm going to use my estimate, so what I think the answer is going to be around, to figure out where the decimal goes in my answer. So I'm going to use the estimate to place the decimal in my product. So these steps, if you follow them, multiply correctly, you should be in a great shape. Step 1, make an estimate. Step 2, multiply and ignore the decimals. Step 3, use the estimate to place the decimal in the product. Let's do some examples. So let's look at an example problem here. We have 2.8 or 2 8/10 times 4 6/10. So 2.8 times 4.6. If I'm going to use an estimation strategy, well, the first step was to estimate the product. So if I'm going to estimate this, probably I would just use a rounding strategy and say that this is close to 3, 2.8, and 4.6 is close to 5. So I'm going to expect an answer somewhere close to 15. I want to remember that I expect my answer to be close to 15. My second step was to multiply the numbers like normal, ignoring the decimals. So if I look at 2.8, if I ignore the decimal, I have 28, and I'm going to use the lattice method for this. And if I have 4.6 and I ignore the decimal, I have 46. So now I'm going to go through and do my multiplication. 8 times 4 is 32. 8 times 6 is 48. 2 times 4 is 8. And 2 times 6 is 12. So now I need to add up my diagonals. So I have 8 here. I have 2 plus 4 plus 2 gives me 8. Here I have 3 plus 8, which gives me 11, plus 1 gives me 12. I'm going to carry my 1 up, so I'll have 1 here. So if I look at my answer here, I would end up with 28 times 46 equals 1,288. 1,288. But I expect my answer to be around 15. So where can I put a decimal at in this number that would give me an answer close to 15? That's my third step. Use my estimate, which was 15, up there, to put a decimal into this number here, my product. And if I want a number close to 15, I'm going to put my decimal after the 2. So I get 12 and 88 which is what I'd expect, a number that's close to my estimate. So 2.8 times 4.6 equals 12 and 88 which is the correct answer. Step 1, I estimated. Step 2, I multiplied ignoring the decimals. Step 3, I used my estimate to put the decimal into the product. Let's try one more. For this example, I have a 3-digit number times a 2-digit number. They both have decimals in it, so I'm going to use my estimation strategy to multiply these decimals. First step is to estimate. So if I estimate 3 5/100 times 6 5/10, I'd probably estimate this at 3 times, say, 7. So I'm going to expect an answer near 21. So my second step then is to multiply ignoring the decimals. I'm going to do traditional method here. Just use different strategy to show that it works for all strategies. So I'm going to multiply the two numbers ignoring the decimal. So if I ignore the decimal, I have 305 times 65. Let's work this out. 5 times 5 is 25. Carry my 2. 5 times 0 is 0, plus 2 is 2. And then 5 times 3 is 15. Let's move over to my tens place, so let's add my placeholder. 6 times 5 is 30. Carry my 3. 6 times 0 is 0, plus 3 gives me 3. And then 6 times 3 gives me 18. And so then I need to add that up. And 5 plus 0, 2 plus 0, 5 plus 3, 1 plus 8, and 1 plus 0. So I end up with, if I read this number like it comes out, would be 19,825. Well, if I go back up and I use my estimate, I need to put my decimal into the problem. That'll get me an answer close to 21, close to my estimate. So it makes most sense to put my decimal after the 9 to get 19.825, or 19 and 825 thousandths. So that is my answer to the problem. 3 and 5 hundredths times 6 and 5 tenths equals 19 and 825 thousandths. So step 1, I did my estimate. Step 2, I multiplied. Step 3, I put in my decimal based on my estimate. So hope that helps. Follow those 3 steps and you should be in great shape. Good luck.